Hi, I'm Mr. V, and this is lesson 12 in Unit 6 about chord geometry. And this is where it's all on the line, is what the title is. I'm just going to go through some of the activities that are in this lesson, and you can follow this if you want to, or you can and take it at your own pace, or you just go through the lesson and then come back here if you need to. A lot of these are either self-checking, they're not self-checking, but they are where I give you the solutions and you can actually check your answers. So an equation for the line that is perpendicular to this line, whose intercept is 0, 5. So we need to go find the slope of this line. So we're going to find two lattice points. Lattice points are points that are on the lattice or on the grid. And I'm going to go I usually start low so that I can go up, and then that would be positive, and then it's either to the left or to the right. To the left would be a negative. So my slope here of this line, the slope of line N, is equal to a negative 2 over 5. What is the slope of a line that is perpendicular to it? The slope of a line that is perpendicular to line N is equal to the opposite reciprocal. So if this is negative, this would have to be positive. The reciprocal will flip it. And now there's a couple of things we could do here. We know that the y-intercept is 0, 5. So we could use the slope-intercept form of an equation of a line, mx plus b, y is equal to mx plus b, where m is the slope and b is the y-intercept, because we're given the y-intercept. So we could write y is equal to 5 halves x plus 5. Another way to do this would be to write the point slope form, y minus k is equal to m times x minus h, where hk is a point on the graph, hk. So I could say y minus 5 is equal to 5 halves, that's my slope, times x minus 0. Two valid forms for writing the equation of a circle. And once we've written this, which was, what did we say it was? Y is equal to 5 halves x plus 5. We're supposed to write an equation that is parallel to n. Again, this has a slope of negative 2/5, that passes through the point 3, 1. 3, 1. It's going to pass through 3, 1. So when we do that, it would have the same slope, which is negative 2/5, and it's going to go, this is my h and my k. And I'll use the point slope form because I've got the point and I've got the slope. Y minus k is equal to m times x minus h. And we write it directly. Y minus 1 is equal to negative 2/5 times x minus 3. Where did I get the 3 and the 1 from? Right here. In today's lesson, we may or may not have time to have done a info gap. This is where you ask questions. The person has a data card. They're looking for certain. The person has the problem card, is looking to solve something. The person with the data card asks the question. What specific information do you need? Well, can you tell me this? Why do you need that information? I need it because, and then I don't have the information, or I do have it, and it is. So here are some of the questions. This was the graph that was given, and the person was supposed to draw an equation of n. And the person with the data card says, what specific information do you need? And he might say, can you tell me, does line N intersect line L or line R? Why do you need that information? Well, if I knew it intersected, I need to know a point, and I need to know the slope of either one of these. And so if it doesn't intersect it, then maybe it's not, I need to know the slope of this. So, and he says, oh, well, let's see. Line L intersects R at 6. So at R is at 6, and x is equal to 6, this is where it intersects. Okay, so that's a point on here. I've got the point 6, comma 1. Now, what specific information do you need? Can you tell me the slope of line line N? Why do you need information? Well, if I knew the slope, then I could write the equation. I do not have that information. And so you see it goes on and on like this, where the person has to ask different questions. And he doesn't know what questions to ask because he doesn't see this. The person with the problem card doesn't see this. He could ask, can you give me a point that it goes through? In which case he says n passes through the point 3, -1. 3, -1 would be right here. And with 3, -1 being a second point, the person could then solve with the slope. I suggest you do it using a t-chart. So we have 6, 1, and 3, -1. The change in x here is -3. The change in y is -2. So the slope is equal to a -2 over -3, or just 2/3. And with the slope and the point on the graph, you can write the equation. There was a second one as well. Here you have this line L is represented by this equation. This would be the slope of this line. Write an equation perpendicular to this that passes through this point. This would be my HK. The slope of the line that was given is 2/3. The slope of the line that is perpendicular to that given line would be the opposite reciprocal. Opposite, we change the sign, reciprocal, we flip it. So with the slope here and this point, we can write the equation. Y minus 4 is equal to -3/2 times x minus a -6, or plus 6. Okay, write an equation of the line perpendicular to P. Well, P, this is line P, had a slope of -3/2. The slope of P is equal to -3/2. So the slope that's perpendicular to it, that's perpendicular to P, would be a positive 2/3. Okay, that's the same as my original. And when we write the equation, y minus a -2 is equal to 2/3 times x minus 3. And you end up with perpendicular lines. This is always the case. I mean, parallel lines here. Yes, because they have the same slope. A line that is perpendicular to two lines that are perpendicular to the same line must be parallel because they'll have the same slope. And that would be a theorem that we could prove. Think of as many different ways as you know to create new lines that are either parallel or perpendicular. The parallel lines will have the same slope. Perpendicular lines would have the opposite reciprocal slope of this line. So we would need to find it. If we translated it, we could do a translation. To rotate it, if you went x, y, and you changed the variables, so you swapped places, and made one of them negative, this would be a rotation of 90 degrees. So this would get you where you wanted to be. You may recall we've used the slope-intercept form, the point-slope form, and standard form. And in standard form, we can find the slope is equal to a negative a over b. And let me show you why that is. I probably should show you why that is. So if I have a point, see, I have ax plus by is equal to c, and I set x equal to 0, then y would equal to c over b. If I set the y equal to 0, then the x is equal to c over a. The change in the x here is going to be c over a. The change in the y here is going to be negative c over b. So my slope, which is the change in y over the change in x, and this is my change in y, this is my change in x, is equal to a negative c over b divided by c over a. And if I multiplied both the top and the bottom by a, these a's would cancel. And c divided by c is c, so I end up with negative a over b is equal to my slope. So with that in mind, let's look at these different equations of these lines. First of all, this line, if I start at these lattice point on the bottom and go up 3 and to the right 1, this has a slope of 3. And we can look at this equation. This has a slope of -3. It's the opposite, but it's not the reciprocal. It will be neither. If I look here, the slope is 3. The slope of this line, this is in the point slope form, is the opposite reciprocal. This would be perpendicular to this given line. Slope is 3. This is 1/3. It's the reciprocal, but it's not the opposite. So this is neither parallel nor perpendicular. And finally, we have this line. So this slope is equal to 3. And what is the slope of this line? This is not in the form that we are familiar with. It's in ax plus by is equal to c. So I've told you in that form you could write the slope as a negative a over b, in which case it would be a negative 3 over 1, which is 3. Also, you can take this equation, you could write it y, we'll add 3x to both sides, get 3x plus 1. This is y equals mx plus b, and you see that the slope is 3. So this is parallel. And that's what we're doing today, was looking at different ways of using parallel and perpendicular equations and coming up with things to solve problems. So good luck and success.